thank you all for coming, and I'm very happy to see so many people here. And I just want to start while we get things set up with a little story. A few years ago, I was in San Francisco and I was founding Lagrange, and someone said to me at an event that in a few years, every app would be a cross-chain app, that it would use a bridge in some part of its function or would have deployments across multiple chains. And at this point, the roll-up vision had yet to be realized. But we were starting to see early signs of people building multi-chain, early indicators of smart money teams making bets on cross-chain deployments. And at the time, it was a bold statement that every app would be cross-chain. But it was one that came true. Like, I can think of very few DeFi apps today that don't have deployments spanning multiple chains, and I can think of very few DeFi apps that wouldn't accept bridged assets, liquidity across multiple chains. The man who made the prediction was right. And this has really got me thinking. I think we're at the precipice of another major shift, and a shift for a proof-based future, a shift for every app in the next 2 to 3 years will use ZK for some part of its design. It might be deployed on an execution space proven by ZK. It might use exogenous data from a ZK TLS provider, or it might extend its execution by using a coprocessor proven in ZK. But at some place in its design, it will need to do something that it can't do on the base layer alone, and that will be powered by ZK. At Lagrange, we are building the infrastructure for that proof-based future. When we look at the evolution of blockchain technologies, we can look at the last generation of POS systems, L1s, sidechain L2s, Oracle networks, POS bridge networks, POS middleware. And we can slowly start to see the hegemony of POS systems erode. And erode thanks to fundamental improvements in ZK infrastructure. And that leads us to the next big step. One where everything relevant to a protocol will be proven in ZK. To prove anything anywhere. And to prove it on one layer, specialized in hyperparallel proving, Lagrange. And what I like to describe Lagrange as in layman's terms is an economy of proving. A universal layer that allows protocols to maintain sovereignty over their proving while participating in the broader global economy of it. Universal and infinitely scalable, specializable, yet universal. And when I say prove anything with Lagrange, this is not a pipe dream or a vision 20 years from now. This is an ecosystem that is slowly developing and unfolding in front of us. On top of Lagrange today, we have protocols spanning DeFi and NFTs using our coprocessor to extend their computation. And we have cross-chain protocols using proofs for interoperability. Many of the top ones in the space, including Layer 0, AltLayer, Polymer, and more. And we are watching unfold some of the best institutional operators in the space take their first steps to run provers with Lagrange. Coinbase, OKX, P2P, Kiln, all of them are participating and lending their computational resources to generate the proofs that power this economy. What makes our design special? Within our network, we have these atomic subunits, these subnetworks. And they have a well-defined architecture that can be replicated at scale, but is modular and flexible insofar as any application can take them and configure them to their requirement. This is how we get to what I call universality with customization. We have the gateway, which is responsible for running auctions of incoming requests. And within the gateway, we have a query scheduler or a computational scheduler that take an incoming request and break it down into the dependent proofs that need to be networked and distributed out. And to each gateway, we have a series of provers subscribed to generate proofs for a given domain. And across all of this, we will have thousands of these subnetworks specializing in different applications ready to scale horizontally. And so a request comes in to a subnetwork, and the subnetwork gateway announces that proving task in a queue. Provers bid to generate these proofs, and the gateway verifies eligibility in terms of staking requirements, hardware requirements, and performance requirements. The gateway then runs an auction, and we'll get into how we have very interesting incentive-compatible auction design for resource markets shortly, and assigns that proof to a winning bidder. That bidder has a period of time to generate that proof and return it back to the gateway such that the next round of proving can begin. And if it fails to do so and fails to meet this SLA, it receives an economic penalty, either in the form of a slashing or a non-payment. And so when we talk about some of the other more traditional proving network architectures, if you can even call any proving network architecture traditional, they are these large monolithic structures. They have a single I/O point. They have potentially a POS chain trying to enforce a global ordering. And they have a bunch of bloat that degrades the performance compared to centralized systems, which means you have these inherent trade-offs between specialization and universality. Lagrange does not believe this is the future if every application needs proving. There needs to be a heterogeneity that doesn't degrade network performance. And that is how we've settled on our architecture. Within each subnetwork, there's specialization. Within the overall network, an internet of proving, there is universality. And the natural balance between the two of those enable us to scale to high proving demands to the TPS of a roll-up cluster ecosystem, but lets us do so without restricting the bandwidth of complementary applications. So we can dynamically scale horizontally without a degradation in performance, which means that the network can sufficiently support complex proving demands from a variety of VM-agnostic systems. We can generate things for coprocessors, for roll-ups, for interoperability, for novel data constructions, for zk-TLS. Whatever you want to build that requires proving, the network can support. And we aren't just saying that our network is this universal thing that you should come and build on and be the first person to guinea pig it for us. That wouldn't really be fair. That's why Lagrange is building the first application on our network, our ZK coprocessor. And powering that is a novel incentive and auction design that our team developed called DARA, double auctions for resource allocation. So what DARA does is match the buyer preferences and seller preferences within each subnetwork. It allows provers to bid on the generation of proofs, matching a specific type or number of constraints based on their hardware requirements and their computational availability, and to generate these proofs, orchestrate them, and return them back to the gateway. And what we can do with this is we can prevent collusion of provers, we can ensure computational efficiency, and we can meet a variety of properties under which the network can be deemed incentive compatible, which means that if you're an application and you know potentially very little about how you would structure a prover network, you just need proofs for some relevant component, we can ensure that all of the complexities over making sure your users get fair pricing and your provers correctly report price are abstracted away from you, thanks to this new research. And right now, we're in production. We have 85 top institutional operators running our provers. We have fantastic research underpinning this. We have operators running everything from bare metal instances to GPUs to whatever type of computational hardware you'd require. So if you need to express preferences as a developer for where your proving is done, we can ensure that the network supports that. And it's production ready. You can be hands-off, trusting that the underlying architecture developed by Lagrange is strong enough to support a production-grade workload of proving. And we've actually already been doing production-grade workloads of proving for many of our DeFi and NFT customers. Our network so far has generated, I believe, about 5 million proofs over the last 4 months across applications ranging all over crypto. And we don't expect to stop here. We expect the proving demand and the proof generation numbers for this network to scale exponentially over the next year. The first thing that we deployed on this was, in fact, architecture built by us, was a proving system developed by our team, our ZK coprocessor. I come from a more traditional venture background, and one of the things that I think Web 2 has actually gotten was this idea of having excellence in what your company does and expanding on that excellence once you have succeeded in a domain. And because of that, Lagrange sought early on to develop a proving system that was tailored to customer needs and could be well suited by our network. And that is what our ZK coprocessor does. It's highly relevant to DeFi NFT projects. It's available in production today, used by many teams, and has battle tested and stress tested the underlying network that we will continue to expand on. And so the way our coprocessor works is you can express a computation in SQL the way you would over a database, and we can prove that computation over blockchain data. And what this means is you can lift heavy computations out of your smart contract into an off-chain network of provers, into our network, then take that proof and verify it back on chain. If there's something too heavy for your smart contract to run, and you want to offload that to ZK, you can do contract simply would register the set of storage slots, receipts, or transactions you care about directly on chain. You would register a query of the SQL statements you may later want to call over that data. And then whenever your users transact and your function requires a generation of a heavy computation, you would call the function and emit an event. The subnetwork for the ZK coprocessor will receive that request and begin the generation process. The query planner will take all of those will take the request, break them in to a bunch of dependent subproofs, and send them out over the network that will then be generated and recursively combined back together. Once that proof is generated, which can take anywhere from 10 seconds to a minute, maybe to a few minutes, depending on the size of what you want to generate computation over, the proof is sent back to the blockchain, and the final result can be verified and used in your contract. Why is that useful? What would a developer potentially want to build on top of this type of ZK coprocessor? Well, an example of this would be a close partner of ours, EtherFi, who is one of the top LRT protocols in the space, has 5 billion in TVL, and is developing a new on-chain credit card for their users. In essence, you can keep your on-chain balance, you can transact with that credit card, and you receive cash back, points, and a whole bunch of things you would expect from a Web 2 experience, but using your on-chain assets. The vision there requires computation that isn't accessible today on-chain. How would I build a cashback program? How would I determine a user's eligibility for points or rewards? The cashback program will be powered by Lagrange. As you transact and fees are generated and the user's transaction volume increases, we're able to generate a proof of the amount that a user has transacted over a period of time and determine that user's eligibility to receive cashback. In essence, you take a well-defined paradigm in Web 2, and you take a forward-looking team looking to bring that on chain, and you pair them with world-class infrastructure and proving infrastructure that lets them do this verifiably in ZK. Another great example of this would be something a little bit more creative, something a little bit more consumer. NFTs. The first generation of NFT projects that we've seen have been foundational to the development of on-chain culture. What it is to be crypto native is hard to separate from the NFT community. But the utility of NFTs has always been locked by constraints on execution on-chain. If I want to build a collector's program to reward you for doing certain things within my NFT ecosystem, how do I do that? How do I check what you do? How do I issue you something on-chain? If I want to let you use your NFT data on-chain in an application, I want to build a game that can search your metadata. How do I do this? All of these things were primitives that developers could not access prior to Lagrange. But with ZK and with our ZK coprocessor, this is now possible. And so I would suggest anyone here who's maybe crypto native or wants to be crypto native or would be excited about the idea of exploring on-chain data to check out this interesting digital experience we've co-designed with Azuki that takes the concept of on-chain data and NFTs and presents it in a way that really allows your imagination to run wild over what you could build. And the last one I want to cover is another DeFi use case, Gearbox. There are a series of well-defined standards in DeFi, the Sushi MasterChef contracts, the 1-inch farming pool contracts that have been used and modified by a variety of teams in the space. But there are limitations in what these contracts can do based on how Solidity can compute over and access data and historical data. You have to accumulate things in current state if you need to use them later, because you can never reach back in the blockchain's history to grab something. With Lagrange and with our ZK coprocessor, we let you do that, which lets you build new and capital efficient financial primitives on chain. And so we have a great series of videos and articles we've written alongside the Gearbox team on this, and they're building one of the first examples of a liquidity mining contract using ZK coprocessing. And what I want to leave everyone here with is a few action items. If you find the vision that I'm talking about interesting, and if you want to be involved, we'd love to have you involved. We'll have some very big updates coming soon in our Prover network. I've talked very heavily about the things Lagrange builds on the network, but as I started with, you can build anything. And we have some very fantastic world-class developers who are building things on top of the network that, frankly, I wouldn't have even been able to anticipate. And expect announcements on that soon. We also have an interesting new community program called the Lagrange Legion, and we have an interactive digital experience to explore all of the ecosystem partners that I've talked about today under the Lagrange universe, which is available on the tablets out front as a sneak peek, and will be available online after Devcon. And please follow us on Twitter and join our Discord. And hopefully I can catch many of you around the event today and meet you guys in person.